Good morning, people. Welcome to class, the last class before exam one, which will be on Thursday. And today we're going to wrap things up. I'm going to review these models of attention and Miller's magical number 7 plus or minus 2, and then present one final thing, which is Miller, Galanter, and Pribram's basic idea behind, in their book, Plans and the Structure of Behavior. So let's start, please, with cameras on. And if you can't turn on your camera, just send me a note. Good to see faces, Alejandro and Leticia. Hello. And Grace and Marco and Otavia. Humans out there. Zaw, hello. And Yasmin. And oh, you hurt your wrist. Katie. Uh, if you said something, I didn't hear it. Anyways,
Oh, sorry. Yeah, I
yeah.
shattered my wrist.
Aye.
Yeah.
Good. Sorry about that. Uh, hope it's healing up. Emily and Layla, hello. And while I'm just scrolling around looking at faces, I won't say hi to everyone. Um, go ahead and let me know if you have questions. Uh, and thank you in the direct messages. Okay, drive carefully. Okay. Uh, yeah, so if you just got here, I'm asking people to turn on their cameras for now. Yes, the exam is open, open note and book, quote unquote book. Uh, Layla asks, is there some kind of study guide for the test on Thursday, or are we going to review at all in class today? Today is an open review after we get through this material, and that's always kind of unpredictable because sometimes people have a lot of questions, sometimes people have few or no questions. And in that case, I may say a little bit of review, but also if there's time, one exercise that we can make use of is to have you all in groups think up questions, and I can explain the reasoning behind that later. There's not a study guide, but all the slides will be presented. You have the recordings, and so a study guide would just be kind of a description of what you have in the slides, and the slides are an elaborate study guide. And it always sounds kind of cringy to me when I say it, but it's true. Your notes should be your study guide. Um, that's part of, yeah. So if you can um, think of it that way, it's a good art to learn, taking good notes. Uh, I'm not uh, averse to study guides, but I do think that the slides are sufficient. The format is much like the quizzes. And a lot of you are taking the harmless practice quizzes, but not everyone. So if you haven't already done that, you should go take those. The they're harmless. You can retake them, and that represents what you'll have in the exam. So some true, false, and multiple choice, and then one written section that is extra credit. You can take it if you want. Any other questions? Uh, so then the I mean attenuation model. And we also looked at Miller and the magical number 7, plus or minus 2. And these are examples of information processing psychology and what was come to be known as cognitive psychology. We and then So here we're not just looking at stimulus and the behaviors thought we ought to. Uh, there's a hypotheses are being formulated about what goes on in between inside that black box. And so you have the information in, and people like Broadbent and Lay and Treisman were asking, how do we pay attention to things? How does attention work? And instead of just instead of just studying stimulus and response and just making claims about the relations between stimulus and behavioral response, they would propose theories. So here's one right here, and in the book, which is only optional now, I mentioned that the arrow, very important arrow going from the selective filter to the limited capacity processor is missing. So that's just an error, an oversight. The idea for broadbent is we pay attention to you're just awash in stimuli, and so maybe you're hearing all these different things. You're at a cocktail party, and you decide to focus on this one person's voice, and so you just don't hear anything else. That was his view. Your selective filter keeps out other things. It does not scan for semantic content. Now, if something explodes, you're going to notice that. So he was well aware that abrupt, unusual, and loud sounds can distract us. But what about something that's not abrupt, not loud, and not that unusual at a party, like another person's voice? Well, uh, there's this term that unfortunately gets used in two different ways, and it's the cocktail party effect. So the less interesting use is just the fact that we can focus our attention and seemingly screen out other stimuli. The more interesting and original, and in my understanding, the original use was it's our ability to be distracted by meaningful utterances that we're not paying attention to. So in the video that I made, I said, if this woman is paying attention to what this guy's saying, and then this woman over here uses her in the purple dress, uses her name, she might be distracted, even if that use of her name is not as loud as this man's voice, um, and not abrupt or really, she'll be you will be distracted when people use your name, right? And if you're studying, you're reading on your laptop at the library. That's probably not. Let's make it a cafe because there's the murmur of people talking and so on. If someone uses your name or just says something kind of scandalous, your attention might be diverted. And so the filter model of attention uh, just doesn't explain. So what we want is we want to go from here to here. It doesn't explain this phenomenon. And it's a simple observation that shows that Broadbent's hypothesis, which is testable and that's good, turns out to predict something that just doesn't happen. Uh, and that often sounds like bad news for a scientist, but you know, science is filled with dead branches, theories that looked promising at first, but made predictions that turned out to be false. And so it's progress when you reject or refute a theory. Just like you're making progress when you're looking for your keys and you go look at your bedside table and they're not there. Okay, they weren't there, but you're making progress. Hopefully, you're ruling out the places where your keys aren't. So the refutability shows that they're doing science, even though they can't directly observe these things. I mean, it wasn't like the selective filter was supposed to be a lobe in the brain where the limited capacity processor had to be some region. That was not what they were trying to do. So, how should we think of attention if it's not the case that we completely filter out unattended stimuli? Again, we don't because at some level we're attending to that stimuli that we're not paying attention to, at least not actively. Because when meaningful things like your own name um, or something scandalous, when those things are said, you can get distracted. Well, Anne Treisman in actually uh, says 1964. I think it was a little earlier that her work. Anyways, that's probably when things were published. Anyways, um, she alters the model simply by saying instead of screening filtering things out, you just pay less attention. So you can think of dialing it down. You're paying more attention to one process of input and less attention to something else. And they would do these what are called dichotic listening tasks. So you'd have headphones on, and they'd say things like, "Pay attention to the voice in the right ear." Or the voice in the left ear, or pay attention to the female voice versus the male voice. So you get these two different voices, and they'd have you pay attention to one. And sometimes they'd have you shadow one of the voices where you would repeat what you were hearing from one ear, supposedly ignoring the other ear. But of course, in that other stream, they might use your name, or they might say something provocative, or like words like fire, or bomb, right, will have low thresholds for perception. In other words, to have a low threshold means it's very easy for that word to break through and distract you along with your name. Okay. And that's the attenuation model. To attenuate is to make thinner. And so you have the input coming in, and when you decide to pay attention uh, uh, to one of the streams and not the other gets attenuated, but it is not completely filtered out. Questions? So they would do these experiments where they would uh, measure uh, whether the subject was distracted by things, and they'd ask them later, was this ever said? Do you remember hearing these words while you were supposedly not paying attention to them, right? Words coming from the unattended stimuli, and then they can measure and predict which words will break through with some regularity. Now, going back to the model, uh, notice that what Broadbent and later and Treisman had to work with was simply the stimulus and the response. So they're not asking subjects to introspect in the way the introspectionists were, and they're not scanning brains, and they're not trying to look in any way at information being processed. I don't know how else you would do that other than scanning the brain. They're just looking at stimulus and response, but there's a hypothesis about what's going on in between, and that hypothesis makes predictions about the stimulus response relations. So it's not that strict form of behaviorism. Okay. So that's the first review. If there aren't questions, I'm just going to pause for a moment. If there aren't questions, we will go on. Um, and it seems to me, by the way, I said there's two uses of cocktail party effect, right? It seems to me that when you just do a search, you'll get the first one. But when you watch and when you read the literature and watch like psychology oriented videos, they maybe more often use may use the second use, where it's our ability to detect important words in unattended stimuli. Another thing I should put probably in the chat and emphasize is let me find it first. See that word semantic? Semantic just means meaning in the following sense. Uh, your name has a sound to it, and people that and the sentence "my dog has fleas" is has a sound to it. But if you speak English, you know what I mean, so you understand the semantics. And if you don't speak another language where they say the same thing, uh, it sounds different, and you don't understand the meaning. It's related because the SEM is related to semiotics. Yes, uh, in some ways very closely related. But semantics is less, I guess, less expansive. It's just the meaning of the statements. And so and it's contrasted with syntax. And syntax is like grammar. So your word processor, let's put artificial intelligence aside. When you're writing, before AI at least, your word processor can tell you when you're making grammatical errors and put like a little green squiggle underneath something where you've done like you failed to make subject and verb agree or something, and it can identify those things, uh, but it doesn't uh, crack the semantics. So if you type in Earth is the fourth planet from the sun, it doesn't correct you on that. So actually, it's a third. Or water is H3O. It doesn't say, well, hold on. Now, of course, with artificial intelligence, you can have systems that do that. You do have systems that do that. Alejandro says, would it be more along the significance of dichotomy? I don't know what that means. Go ahead and unmute yourself if you want.
I was just wanting to clarify if it was more like syntax and the other has to do with the choosing of words and I guess instances of how they convert, I guess, transfer different meaning when you use different words as opposed to different things. I think.
I'm sorry, Alejandro. It's your message isn't coming through very clear. It's kind of garbled. You go ahead and put it in the chat if you want. Um, and so right. What else can I say? Oh, there's a famous example of that helps with syntax and semantics that we get from Noam Chomsky. We saw him a class or two back, and it's the following sentence. Um, Colorless. And someone needs to turn off their microphone.
I did. I just turned off my headphones because they,
That works.
yeah.
Okay.
And I was saying that like the use of, I guess, semantics or syntax when it comes to dichotomy, like the use of certain words changes the meaning, even though you might be referring to the same thing.
Yes.
So I was just wanting to like infer if that is a bit different when you're like choosing between a certain word and also saying like, I guess the meaning of a certain sign when you're referring by using a certain word.
Yeah, semiotics gets more into like euphemisms and slurs, and there are words that maybe strictly pick out the exact same thing, but they connote different things, uh, and I mean that can be part of semantics as well. Yeah. Um, the sentence that I put in the chat is colorless green ideas sleep furiously. There is nothing syntactically wrong with that sentence. It's got a noun phrase, colorless green ideas. What do? Predicate, sleep furiously. That's also known as a verb phrase. In the noun phrase, you're talking about the noun ideas. It's plural. It's qualified with green and colorless, right? But what does it mean? What does that mean? Uh, Now, if you're a poetic type, you might say, "Oh, I know what it means," but I bet you that you put all the poetic types in separate rooms and have them write down what they think it means, and they're going to give very different answers, right? So it might cause you to think of things. We're very associative, right? So it might make you think a certain way and have ideas in your head, but it's not going to reliably put the same ideas in different heads. Um, to be an idea is to be something that can't have a color, and so to be green is to not be colorless, and so you have these contradictions built in. And how can an idea sleep? And granting that somehow an idea can sleep, how can something sleep furiously, right? So it's the semantics of these words that tell us that nothing fits together. It's internally in conflict. But the syntax is fine. There are no grammatical errors here. Okay. Good. And so the interesting version of the cocktail party effect, the fact that your name and certain other words can distract you when you're not paying attention to voices that are even quieter and distant, etc. The fact that that can happen rejects Broadbent's model, Ann Treisman replaces it with the with the attenuation model. And again, to attenuate is to make thinner, less substantial. Okay, good. So I included as an optional reading George Miller's paper. I also quoted the first two paragraphs in the video, and I was heartened to see that most of you are watching those videos, but apparently not everyone. And so if you're just not aware, not paying attention, I do post these videos, and I try to keep them. Uh, they're going to typically be 20 to 30 minutes, sometimes a little bit more. I think that's what happened this time, but often less. Okay, so Miller writes tongue in cheek about being persecuted or followed, stalked by this number. It's everywhere in his research. He just keeps coming across it, 7 or thereabouts, very close to 7. So he calls it 7 plus or minus 2. Whether we're looking at discrimination between, say, tones or shades, or memory tasks, or judgment, or ability to press the right button within a certain period of time, it seems that we start making errors when we get close to 7. So 2, 3, 4 things, easy. 5, maybe you'll get a little bit of error. 6 and 7, you get much more error. And 8 and 9, it becomes hopeless, right? And so why is this? Because that's how the novice is, but we can get better at things. Like you can get better at a video game, you can get better at playing piano. You can, even when it looks like you're processing 7, 8, or 9 chunks of information, you can get better at the game of chess, right? So how does this work? And of course, as he says, you can get better at Morse code, which is, dit, 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 da, 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 dit, 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 the way they used to transmit information long ago. And he says, a man beginning to learn radio telegraphic code, that's Morse code. Morse is, I'll put that in the chat. It's named after the person who came up with it. Such a person hears each dit and da as a separate chunk. Soon he is able to organize these sounds into letters, and then he can deal with the letters as chunks. Then the letters organize themselves as words, which are still larger chunks, and he begins to hear whole phrases. And of course, that's analogous to what happens with us when we learn language and when we learn to read. So what are we doing? Well, we are recoding or chunking. Now, those of you who watched the video, I gave you a 10-digit number to remember. Can anyone remember the number? You can put it in the chat. I was pretty casual about it. I was purposely casual. Okay, Marco, yep. Grace, yes. Interesting, Layla, right? I was purposely casual about it because I didn't want everyone to put a lot of time and attention into it, because my point is you don't have to. Batavia's got it. Caitlin's got it. Good. Okay, how did you remember this number? 10 digits. You can put your hand up, you can unmute yourself, or you can type something in the chat.
I thought of it like an area code, like 415 San Francisco area code, and then like a phone number, and then 1945, like the year 1945, and then just 747, but that was the same number.
You mean it was like symmetric?
Yeah.
Is that what yeah, okay. Interesting. And Marco says area code, plane, World War II year. It's the year that World War II ended. Also the year that the atomic bomb was dropped on Hiroshima and Nagasaki. A pretty impactful year. And even if you don't know those things, like 1945 is probably evocative to you. And Layla wrote, I only remembered the first 3 because it's the Bay Area code. Yeah, that was all intentional. So I purposely, and yes, there's a plane called a 747. A lot of people don't know that, but you might, and it might sound familiar. But notice that Marco wrote 3 things. He wrote area code, plane, World War II, year. That's three things, not 10. So you all of you that did this, and I'm going to guess that most of you didn't have to work at this. You just looked at the number and went, well, there's the Bay Area area code, and there's 747. Maybe some of you see that as a plane. Maybe you just saw it as a symmetric number. And then 1945 is a very evocative year. Not all numbers permit this, or it's not so easy with all numbers, but you will be surprised how long a string of numbers you can memorize if you think of it this way, if you look for meaningful chunks. And so this is his view. When you become an expert at something, or when you just get better at something, you're taking a bunch of information that you have trouble juggling and processing in your mind, and you're chunking it into meaningful chunks. You're recoding it. Your brain's not getting bigger. It's not growing an extra lobe or anything. There are physiological changes taking place in your brain. We now know that. But conceptually, what you're doing is recognizing meaningful chunks. And this, by the way, is how chess players play chess, right? When you're learning chess, you have 20 pieces on your side, 20 pieces on the other side. So you have 40 pieces, and you have an 8x10, 8x8, 64 squares on a grid. All these rules you have to memorize. So you're juggling all this information. But as you get better, you start to instead of seeing, oh, that pawn is diagonal to this next pawn, which is diagonal to the next pawn, instead of seeing that, which is maybe three or even depending on how you think of it, maybe even five pieces of information, because there's the three pawns and then their relations. Instead of that, you just see a Sicilian defense. And that's just one piece of information. And they tested this, and this is kind of cool. So they take a chessboard with a layout, and it's something that you might see in a chess game. And the chess expert and the novice get flashed that image for, I don't know, a quarter of a second or something. So it's flashed, and now you're supposed to reproduce what you saw. And the experts do far better than the novices, because they don't see a bunch of little pieces on a bunch of little squares. They just see a few things like Sicilian defense and the blah, 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 whatever. They don't have to have names. The novice is trying to juggle more information than the expert, right? Then they flash a board where the positions make no sense. You would never see this in an actual game of chess. And guess what? The experts are down to the level of novice. They have trouble reproducing the board. And in some cases, children do better than the experts, because the experts just don't have the processing for these unfamiliar board layouts. And remember what I just said about 10-digit numbers, right? And how you could use this to remember a 20-digit number or a 50-digit number. In a way, you've been doing this all your life. So if you remember this sentence, for example, you can more easily remember the following string of 10 of numbers. Whoops, I need to correct that. let me find a better example. Recoding, as we'll see, involves creating hierarchies. Any one of you can remember this, right? Recoding, as we'll see, involves creating hierarchies. If someone did not know what you were doing and you wrote this on the board, it would be naive, but they might think, wow, this person can remember, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What is this, like 30, 40 symbols in a row? It would look like you remembered a 40 plus series of symbols. And in a sense, you do remember that, but you're also kind of cheating, because you're just looking at a sentence. Recoding, as we'll see, involves creating hierarchies, and all that information is packed into those chunks. And as we'll see, for you might be just one chunk, whereas for someone else they might say, no, it's the words, as we'll see. And then someone might think of the will as it breaking into we will, right, and being put together. The point is, there's a lot of information packed into this. And someone who doesn't understand how you're doing it will think that you have the power to remember R is followed by E is followed by C is followed by, right? Okay. So that's recoding. And here in the review, I showed you this, which was an internet meme going around long ago. And people who can read English have no trouble, quote unquote, reading this. And I put the question mark there because it's recoding, but it might involve a little bit more than recoding. And notice that the words that are 4 letters or longer have the letters in between the first and last letter jumbled up. So according is horribly misspelled. Research is horribly misspelled, but somehow you're able to read this. And this says something about how we actually read. And so that last sentence is, there it is all mixed up, but I'm going to put it in plain English. It's almost as easy to read as this. This is because the human mind does not read every letter by itself, but the word as a whole. And that's roughly true. I have an asterisk here that says it's not perfect. It doesn't perfectly work with all words because some words are ambiguous when you do this. And it actually came from someone's work at UCLA, not Cambridge. So whoever originated this meme either just made something up or was confused about that fact. But the phenomenon is, of course, real. Okay, I thought I'd ask you some review questions. While both behaviorism and cognitivism are concerned with stimulus and response, what distinguishes the view? So they both acknowledge stimulus and response, but what does cognitivism add? Think about Broadbent's theory and how it was refuted and replaced with Treisman's theory. Think about what I keep saying about the black box, how the behaviorists didn't want to discuss what was going on in between the stimulus and the response, or thought that when you did, you were somehow departing from doing hard science. Recall Steven Pinker's description of the cognitive revolution in the video that we watched last time. What's the difference? Otavia says study of what was going on in the black box. That's right. And what is going on? Well, the cognitivists, the cognitive science, they call it mental content. So we're talking about memory, judgments, perceptions, images, etc. Mental content. Things, yes, exactly, Yasmin, and it's unobservable by the researchers. Now, presumably you have mental content that you observe, I have mental content that I observe, but the researchers can't get at that. Not everyone agrees with that, but it's a pretty common view. Okay, so they dare to make scientific claims about mental content, even though they aren't necessarily doing introspection, but some of them do. Number 2, after behaviorism, we started talking about Claude Shannon and information theory. Shannon was not trying to do psychology, so why are we talking about Claude Shannon and information theory? He's the the kind of the founder of information theory. Why are we discussing this now? What does information theory have to do with cognitivism, the mind, or the brain? Remember what I taught. So Grace says to think about information as a measurable quantity, and then you want to tie it back to cognitivism, to the mind, because he was trying to explain how we processed information. Okay, so that's very close, but Layla, he wasn't trying to say he wasn't trying to do psychology. He was working at Bell Labs, and he just wanted to have a theory of information so that when telephones were, people were sending signals over telephone lines and the satellites and whatever, so that we could think of that from a kind of an engineering standpoint, think about it formally and mathematically. But psychologists who were dissatisfied with behaviorism saw that what they were doing in computer science is studying these gadgets where they would look at the input and the output, but also the information processing in between. And so he wasn't trying to explain how we with our brains process information. He was just trying to explain information processing. And then the psychologists were saying we can study the brain in the same way, just as they study the computer in computer science in terms of input, output, and the processing that goes on in between. So can we study the brain in terms of stimulus and response and the processing that goes on in between. Good. What is okay, so I just taught the cocktail party phenomenon gets used two different ways. So it's, I think, more colloquial and commonplace for people to say, it's your ability to focus on some stimuli and ignore others. By the way, some people have a lot of trouble with this. And so when they're at a party and there are a lot of people talking, it's hard for them to listen to what there's one person talking to them, and it's hard for them to actually pay attention because they're constantly distracted. And then the more interesting version, which I'm calling use two, is that phenomenon by which when something meaningful is said by someone else in the stream that you're not attending to, it distracts you. Darla says, what about ADHD? I don't have really any clinical experience with ADHD. I only understand it as a layperson, but I would not be surprised if that's part of the challenge. If you have ADHD, I wouldn't be surprised being an attention deficit, if that's part of the challenge, is focusing on something. Yeah. I've been told, so I've never been diagnosed with ADHD, and I have no idea. But if I would be diagnosed with it, I'm not trying to suggest that I would be, but I have been told that when I'm at parties, I'm constantly looking around, and I have to manage that because it can seem rude, and at least from my own first person point of view, just things happen, and I just get distracted. And people used to tease me about it. And occasionally, yeah, I would maybe offend someone. So I've learned to not do that as best I can. And then how does it relate to Broadbent's filter model of attention and Treisman's attenuation model? Someone want to do that? How does this cocktail party relate to Broadbent's filter model? There's a very simple answer. It shows that the model blank doesn't work. Thank you. Yeah, it is wrong. Yeah, it refutes the model strictly. And so we replace it, or you might say update it, right? So he laid the groundwork, but it made predictions that turned out to be false. And Priesman's model is the attenuation model, and it can handle these facts, this cocktail party phenomenon. Now, there are shortcomings. There are things it doesn't do. Like it doesn't explain context sensitivity, and why does the word fire more easily distract this person than that person? There are priming effects, so you can prepare a subject to become more sensitive to certain words. So it's not like a complete model, but at least it explains the cocktail party effect in the second use. And then finally, what is Miller's magical number 7 plus or minus 2? What does it measure, people? Manzi says short-term memory. In a sense, yes, it measures our capacity to judge, discriminate, and remember a number of items. Yeah. How many chunks of information we can memorize? Yes. How many chunks of information you can handle at a time? Yes. Good. And so how do we explain the chess master who seems to be juggling all this information, all these chunks? Well, they just recoded, they've rechunked things. And that's part of learning and getting better at anything. And you can do this self-consciously. You can purposely chunk things. And I recommend not just coming up with one set of chunks, you can also kind of overlap chunks. So it would be kind of like, you look at you look at the continent of, the part of America that is the United States, and then you can break it up into states, but you could redraw in your imagination those boundaries, or you could read history and look at the different boundaries throughout history. And so rechunking things in that way can be useful as well. Okay, this is the last thing for me to present. And we call these three psychologists MGP: Miller, Gallanter, and Pribram. And in 1960, they wrote a book which was kind of one of the breakaway books. It was part of the cognitive revolution. It was it breaks away from behaviorism because they're trying to explain structured behavior using things like plans. And plans are not in the stimulus, they're not in the response, they're in between. And so they say, we've had this gap between stimulus and response. It's time to let go of trying to do psychology by only looking at the stimulus and the response. We need to give something of a cognitive account. Open up the black box, remember? So the strong behaviorists say, look, there's no sense in speculating about what's in the box. You can't test it. You can't directly observe it. And MGP say, yeah, of course we can. We can test these things even though we can't directly observe them. And so they propose that they explain structured behavior because we behave in structured ways. We don't just get triggered by the environment moment by moment. We can sit down and play piano. We can, you can build a birdhouse. You can do all kinds of interesting things. And the question is to explain that. And so they propose that behavior might break down into fundamental units. And go way back to our first week when you read the paper by Gary Marcus. And he wanted to break down human cognition into field programmable arrays. Okay, they're gated arrays, but he wanted to break human cognition down to basic units, kind of like cognitive atoms. And this has been one of the ambitions in psychology and more broadly in cognitive science, is to see if human behavior, human cognition, or maybe some aspect of human cognition breaks down into fundamental units that when they can be nested and put together in different ways. And that's all you need to explain everything else. Just like, there's a sense in which all you need are atoms to explain a lot, maybe not everything. There's subatomic particles, of course, but to explain a lot about what we know when it comes to the material world. And so they propose TOTE, TOTE, and it stands for test, operate, test, execute. And I'll put that up in a slide in a second. So they bring more than just stimulus and response. You have different levels of analysis when it comes to some behavior. The subject who's behaving has what they call an image, not the best name, but it's representational. It's the knowledge that the organism has about the world and itself. Knowledge used here is not, it's just the beliefs and the model that it has of the world. So it doesn't have to be true. Sometimes philosophers say, well, if you know it, then it must be true. What they mean is just your representation of the world. And then you have a plan, and this is how you're going to behave so as to obtain some goal. And then you have some way of executing that in the real world using behavior. And that controls the sequence of operations. Now, the plan is that's where these psychologists, I'm sorry, the image and the plan are where they break away from strict behaviorism, because they're saying we have to understand organisms as representing things. So the image represents how the world is and how the organism is. And then the plan involves how they want it to be. So there's an apple in the tree. You don't have the apple. You know you don't have the apple. You know the apple's in the tree. So that's your image. Your plan is to get the apple, and maybe to get it by grabbing it. And so you're hoping the organism that engages in this structured behavior is hoping to bring into alignment the way the world is with the way the organism wants the world to be, which is I have the apple. It's like the challenges of life, the way the world is versus the way that you want the world to be. And so that's what we do. They think the tote is going to explain all of this, and you can have different totes, and they can be nested, and they can relate to each other, but they're like little algorithms, and it stands for test, operate, test, exit, and um, and I'm going to give you some examples in a moment. Uh, if you code and like to code and think about algorithms, then you might be a little irked by the fact that they call them totes, because it looks like what it's describing is something that tests once, then operates, then tests a second time, and then stops and exits and moves on to do something else. But that's not the case. So it could test, operate, test, operate, test, operate, test, operate any number of times. Or it could test and exit. And I'll give examples of that. So let's say, wait. Oh, so yeah. So here's the algorithmic way of presenting it. So you test a situation to determine whether a goal has been achieved. And if it has, then they're in alignment, they're in congruity. They are in congruity. But if the goal has not been achieved, then you have an incongruity, you have a mismatch. So just think, you test, is there a match or not? If there's a match, exit, move on, right? If there's a mismatch, you have not achieved the goal. The way the world is not the way that you want it to be. Then you operate in some way so as to improve the situation, hopefully, right? You perform some kind of operation. You're looking for your keys. I don't see my keys. You keep looking. Okay. You're hammering a nail. Well, you probably want the nail head to be flush with the surface that you're hammering the nail into. Let's say you're on a roof and hammering the that paper. I forget what they call it. And you see the nail head is up. So you want it down. There's a mismatch. So you operate, bam, you hit it once. And unless you're really handy, it's still not flush. So you test again, you acknowledge that it's still not flush. So you're in a loop and you're just pounding the nail until it becomes flush. And then when you test, there's a match between how you want the world to be and how the world is, and you exit because the nail is flush with the surface. You pounded the nail into the roof or whatever. Now, while you're doing this, you also have to pay attention. You don't want to fall off the roof, for example. So there's a larger tote that you're within, which is don't fall off the roof, right? And if while you're hammering the nail, you start to fall off the roof, then you will you'll be testing for that, maybe not in as self-conscious a way, but on some level you're always hopefully testing for that. And now there's a mismatch between how the world is and how you want it to be, because you want to be on the roof, not falling off the roof. But now the world is you're about to fall off the roof, and so you execute hopefully in some way to keep yourself from falling off the roof. And then when you complete hammering that nail in, you go into a higher level tote, which is find the next nail that needs to be. We're imagining it's this isn't really how it works, but we're imagining a world where there are a bunch of nail heads popped up a little. I guess that does happen in time. Um, in time the nails get squeezed out. You might have noticed that on fences. So I guess it's more real world than I first let on or suggested. Okay. And so there can be any number of test and operate loops. And this is supposed to explain behavior. And because it's hierarchical, it doesn't just explain like you just sitting there hammering a nail until the nail head is pounded in. It explains more interesting behavior. I'll give another example and use this as an opportunity to express my disappointment with the video game. So a long time ago, I'm not like anti-video games, but my friend really, really wanted me to play World of Warcraft. And I said, okay. So I sat down and I don't know what the game's like nowadays, but basically I was supposed to just go find a giant rats and hit them with a stick until they died, and then I get gold. I can't tell you how boring this was for me. I'm literally just clicking the mouse, click, 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 and then right. And for the day, the graphics were wonderful. And I know it gets a little, I know that the game goes beyond that. It's much more interesting, but I just couldn't get past that, right? So you can describe this in terms of tote. You test whether the monster is dead. If it's dead, you exit. Uh, if not, you click the mouse, and you're just in this tote loop, this very simplistic tote loop until it dies. And then when you're done, you go into a search tote. You look for another monster to go fight. Right. Um, remember Skinner and what he had to say about uh, gamblers. Well, you can explain that behavior in terms of totes. Test whether or not you make money. If you make money, you exit. And if you're addicted to gambling, you probably go right back in. But you exit into a tote, which is find something else to do, and we could try to give a more interesting description of that. But for this one, if you haven't made money, you operate by depositing money, and that involves a subtote because you have to be able to behave correctly if you drop your money before putting the coin in the slot, etc. And then you just test again, and you're just in a loop, right? Um, if that's your idea of you know of gambling fun, right? And so those are three examples of totes. We can wrap this up with the following comparisons. Oh, Yasmin, go ahead.
Yeah, I just to add, or just the question, we kind of talked about this, I think, early in the semester, but about how marketers use psychology or different ways of thinking, right? I guess. So totes, this just made me think of that. Like this is something they would expressly understand, right? Or just because you're giving the example of the gambler, the people at the slot machines, right? And they're like going back and forth, and they're in this loop. And then so it's sort of this idea that you can also create these loops for people, right? In a way.
Yeah, I think so. I think the connection to conditioning is stronger, but yes, I
Okay.
think I wouldn't be at all surprised. I don't know. There's a lot I don't know about marketing, but I wouldn't be at all surprised if um, there were marketers who took from behaviorism the lesson that you can condition people to perform this behavior, and then they would try to, I suppose, take advantage of these kind of predictable test operation loops that people get into to sell
Uh-huh.
products, to sell
So
products.
yeah, it's fascinating. Okay, thanks.
Sure. Um, yeah, good. And so look at how these compare with computers. They were very self-conscious about this. They realized that they were inspired by computers. Um, to an extent. And so the images are representations of the world, just like computers have data structures that represent the world. The plans and the operations control what the system does. We're talking about people, right? It controls their behavior and other organisms. And the program controls what the system does. And totes can be nested like programs and their subroutines, right? And in every case, you have a kind of an attempt to explain behavior in terms of trying to achieve uh, a match between the way the world is and the way that you want the world to be. Okay, good. Yeah, we have a good amount of time. That takes us to the end of all the slides, and I'll post these slides after class. Or no, I think I've already posted these actually. If anyone knows that, you can say something in the chat. I think I usually wait until I presented everything to post them, but I thought I'd let you have access to them. So the slides would be called cognitivism. Any questions?
For the slides, I'm not sure if it's just me, but there's only the introduction and then the empiricism, association, and introspectism one.
Let
The
me,
rest are
okay, thank you. Let me go see. I might have misremembered. I have 5 different classes. So thank you for oh good. Yeah. So I'll um I'll post the behaviorism and cognitivism slides. Yeah. Thanks. Other questions? Okay, so the main so what did we do? We had an introduction and we started with Gary Marcus argument and you might say the arguably extreme view that the brain is a computer, which represents what has been a working hypothesis in cognitivism. It's not what all cognitive scientists believe. We looked at some theories of the mind. We discussed, then we got into empiricism and associationism, and then also closely related introspectionism and the problems for that view. When we looked at empiricism and associationism, we looked especially at John Locke and William James. I can say more about any of that. Then we discussed the challenges with for introspectionism and the theory of behaviorism or the family of theories as promoted by John Watson. We also looked at Pavlov's dog and Little Albert, B.F. Skinner, etc. And then some challenges for behaviorism, the cognitive revolution, and we've just been discussing cognitivism. In challenges for behaviorism, we saw an attempt to explain sequential behavior, challenges that arose for the most radical forms of behaviorism, reflex chaining. We also saw a criticism from without by Noam Chomsky, which is criticizing the way that B.F. Skinner thought he could maintain a law-like relation between stimulus and verbal response, hoping to explain human verbal behavior. And then we got into information processing psychology and cognitive science. And as you saw today, we discussed Broadbent's model and Treisman's attenuation model. So Broadbent's model is the filter model. And Treisman's is the attenuation theory or attenuation model of attention. And Miller's magical number 7 plus or minus 2 and totes. If there aren't questions, then let's do this. last chance to ask questions before we do something else. I'm going to put something in the chat. Um, Bear with me. I'm a slow typer. Um, is that good? In a direct message, yes. Someone just sent a direct message. Um, okay, we're gonna have 4 groups. I think we need more though. And let me reply. So Zaw says, I remember in computer memory that they have an error correction bit. Um, I'm not sure what you're referring to. If you want to write more, go ahead. And then Grace writes, can you provide a quick recap of the defining differences between empiricism, rationalism, associationism, and introspectionism? Yes. Good. So I'm trying to do a few different things at once. So let me start with Grace's question. Empiricism. Now, outside of this class, it can mean a lot of different things because it can be a theory about knowledge, a theory about learning, which is different, a theory about how we should understand the world. Okay. But in this course, we're using it as a theory about knowledge and where we get what furnishes the mind. So how is it that you have the idea of the snowball? Well, the empiricist says you can't have those ideas without experience. So you have the roundness idea, the coldness idea, the whiteness idea, etc. You got that from experience. You did not come into the world with snowball ideas or even with the parts, those simple ideas. The rationalist says the way we're using these terms, that some ideas are innate. And the empiricist says no innate ideas. Innate means it's born into you. The rationalist might say, how do you have the idea of God? Even the atheist has the idea of God. You have to have an idea of God to deny that God exists, right? So you have the idea. Where did that come from? There's no, infinitely powerful, infinitely good being that we experience in the faulty limited world, or just infinity. How do we have that idea, right? So the rationalists will say that we come into the world with some, not all. I mean, they'll agree about the snowball typically, but they might also say even the concept of a perfect circle. You never see or feel a perfect circle. There's always some flaw. There's always it falls short of the perfect circle, and yet we have the idea. But because to notice that something falls short of the ideal is to have the ideal, right? So it must be born into us. Um, that's rationalism. The associationist is very much like an empiricist, except now where they're saying that we learn to form associations between things through experience. So remember the image of the girl releasing the cup's falling. Well, the baby, according to the associationist, has no expectations. But after some experience, you start to learn, okay, when cups are released, they fall downward. Right? Later, you learn that when a helium balloon is released, it goes upward. Right. Uh, and children at some point they're not impressed by helium balloons because they have no expectations. But once you've gotten used to almost everything falling downward, when you see something go up, that attracts your attention. So we looked at that violation of expectation video about the Minnie Mouse doll and so on. So the associationist is typically an empiricist, but they're making an additional claim about how we think. So how do we think? We associate. Our minds just follow these associations. And where do we get those associations? Experience. And then introspectionism is a term for a methodology of how the mind should be, how we should do psychology. How should we do it? We should train subjects and present them with stimuli, and then ask them, what did your mind do when you had that experience? It could be as simple as comparing two tones and saying which one sounds louder to you, or even by how much. Does it seem twice as loud, etc.? But it could be something else, like when we asked you to do word association, when you saw the first word, how did you get to the word that you associated it with? What were you thinking? Did you have an image in your mind? Did you have a memory of what you did this morning, etc.? So that's introspectionism. And behaviorism is, it's the stricter forms of behaviorism are views according to which psychology should be a rigorous science, and that means we should focus on what's publicly observable, the stimulus and the response. But if there is something else going on inside the mind, mental content, thoughts, perceptions, judgments, etc., we have no direct access to it. We have no public access. So as rigorous scientists, the behaviorists said, we should study what's publicly available, and that's stimulus and response. And they would add the record of the schedule of reinforcement. So there's a past record of how this pigeon, was trained, given reinforcement pellets and so on. Now, I always say this, there were behaviorists who were perfectly happy to talk about what was going on in between stimulus and response, but they thought, that's just something science. You're not doing science when you do that. You're doing something else. And then there were the more, I don't know, ideological ones who would ridicule talking that way. And sometimes, Watson and others that were more ideological would say, I hear you saying that when we look at an optical illusion, we have a visualization in our head, we imagine, or we have an image or something. I don't know what you're talking about. And that's why I read you Watson's preface. Okay. That I didn't realize how much time my answer would take. I was going to have you come up with your own questions, but we've run out of time to do that. So I'm just going to talk about the value of doing that. And maybe next time, in preparation for the next exam, we'll actually do that. But oh, thanks, Krizia. Good. I may have already said this, but the thing you learn when you have to teach, the moment you have to teach something, I remember learning this when I became a grad student, and I had to run a discussion session in symbolic logic. You might have done very well in a class, and in a bunch of classes, all related to the same thing, gotten A's in all of them, and feel like you totally understand it. Now you have to teach it, and you realize there are all these dimensions that you never really thought about, because you have to start thinking, what are the ways that people might misunderstand this? How might someone be convinced that they understand it when they don't? And so the short version is, to be a good student, it helps to think like a teacher, like an instructor, like a professor. Don't ask yourself, do I have a good feeling when I think about the concept? Like, do I feel like I'm in cognitive fluency? Because it may just seem familiar to you. And that's good as far as it goes. But ask yourself, could I create exam questions to test my own knowledge and to test knowledge of others? And it's got to be objective enough that it's fair. It's got to be the wrong answers should be such that you can point to the lessons and say, here's where that issue is resolved. Here's how you can know that that's not the right answer. And the same goes for the correct answer. So there should be something in what I teach, in the lessons, in what you read, in what you view the videos, where you can say, see, that's where they answer the question. And then there's a kind of an art that you just have to figure out to, if it's a multiple choice question, making sure that the right answer isn't obviously, glaringly the right answer. So the wrong answers can't be obviously wrong. And I'm sure you've all had that experience where you look at some exam for a class you've never taken, and sometimes you just look at it and say, well, I'm pretty sure that's got to be the right answer. And if you're right, then that's not a very good test question. I mean, inevitably there are going to be some like that, and should be, by the way, and there should be, because you need to test the range. So so the instructor's job when they write an exam like this is to try to come up with a fair way of assessing the level of understanding that students have. And there's the A level and the B level and the C level, right? And so it it will help you think. It will help you think about and prepare for the exam if you come up with some of your own questions. And the first thing you'll notice, because sometimes we workshop this in class, is how hard that can be. Yeah. Good. So ask yourself, how would I teach this and how would I test this? It's something that when I bring that up to other instructors, their eyes get all wide and they start nodding, and everyone agrees that this is something they all wish they knew when they were students. Okay. So what I was typing, I'm just not gonna, I was trying to type categories. So brain is computer. Actually, I'll just put it there. Okay. Separated by commas. I was going to divide you into groups and have one group work on this brain is computer thing. So you'd be coming up with a question from the Gary Marcus article, and the second group was empiricism / associationism. Third group was behaviorism, and the fourth was cognitivism. So under cognitivism, is if that was your group, you could have come up with a question about totes or the attenuation model, etc. And now for a moment of awkward silence. Anyone can ask anything. We just have a few minutes left. Oh, Isabella, go ahead.
So my question is, there are going to be like multiple choice questions, and then you mentioned one like writing question at the end.
One extra credit, short essay question, true, false, and multiple choice. That's required, but the writing is extra credit.
Okay, cool.
All right.
Thank you.
And you're welcome. Grace says, what ismist would you define Noam Chomsky as? Well, the way we're using the term, he would, I mean, you have to be careful with him, but most of us would count him as a kind of rationalist. We come into the world with a kind of innate knowledge, and it's a language acquisition device is what it's sometimes called, also called a language organ. That's not to say that it's a lobe of the brain, but we come in with certain language acquisition capacities. So we are not blank slates. So that makes him a kind of rationalist. Naomi, yes. The harmless practice quizzes are intended to get you ready for the exam. So they're the same in form. You're just going to have more on the exam. And of course, you can't retake it, and it's not harmless. You're welcome. Anything else? Well, B.F. Skinner, hang on just one second. I'll get you. B.F. Skinner was a behaviorist. That's, I'm not saying he wasn't an empiricist, but it was his behaviorism that that we're learning about. The journal hasn't yet been announced. It will be. Okay, who was it that just spoke up? Go ahead.
My question was for the recoding for, you know, how you said like someone would see the word, if someone has like dyslexia or things like that, would they code it differently or would they just not be able to?
Well, if you have dyslexia, you can still recode. I mean, and again, there's a lot of clinical training I just don't have. So, but if you have dyslexia, you just have trouble organizing and sometimes recognizing letters. But that doesn't mean you can't learn to read and do all kinds of things. And so, yeah, you're still recoding, although the dyslexia might make it more difficult. Okay, so it's now officially a minute after class. So class is dismissed, and I'll stick around in case people still have follow-up questions. Otherwise, best wishes, preparing for the exam and taking the exam on Thursday. The window opens at 8, closes at 11:59 p.m. on Thursday. You can start it whenever you want, but that's a hard cutoff. So don't wait until the last minute because the window closes. That will close your exam as well.
Thank
Who
you.
wants to take one at 11 at night anyways? Yeah, you're welcome. Okay, I'm going to end the recording.
Thank you.
Thanks, everyone.